Hello. In this video, we're going to look at the concept of a z-score. So z-scores are a way of comparing distributions with different means and different standard deviations. So let's say, for example, you have a test where you got 63% and the class average was 68 with a standard deviation of 7. And you got 65% on a different test when the class average was 70% with a standard deviation of 9%. Now, in each case, you got a little bit below the mean, but what we're looking to decide is, relative to the rest of the class, on which test did you have the strongest result? So it's not just about comparing it to the mean, it's also about comparing it with the standard deviation, and that's where z-scores come in. So a z-score is the difference between a particular value and the mean, so your score minus the mean, divided by the standard deviation. So this essentially will give the number of standard deviations above or below the mean. The z-score will be positive if x is bigger than the mean, and it will be negative if x is smaller than the mean. So what we get when we do this, z for the first test, would be 63 minus 68, divided by the standard deviation, which was 7. So in this case, we end up with approximately, so 3 significant digits, negative 0.714. And for the second one, where we have 65 minus that mean of 70, so again, negative 5, but this time divided into 9. So that is going to give us approximately negative 0.556. So essentially, in the first one, we're about 71% of a standard deviation below the mean. And in the second one, a little under 56% of a standard deviation below the mean, or a little more than half of a standard deviation compared to a little less than 3/4 of a standard deviation. So the one where we're closer to the mean, the higher z-score, is the one where we have a better performance relative to the rest of the class. Because in each case, yes, we were 5 points below the mean, but in the first case, there were more people who were within 7 points of the mean, 7% of the mean, versus in the second test, most people were within 9% of the mean. So there would have been more people with lower scores. So let's consider that we have a particular flu with an average length of 6 days, with a standard deviation of 2 days. We want to know the probability that this flu will last longer than 8 days. So this chart right here that you've seen before is essentially giving z-scores, one standard deviation above, one standard deviation below, and so on. So we want to know the probability that the flu will last longer than 8 days, so let's convert that into a z-score. So the z-score for 8 days is 8 minus the mean, which was 6, divided by the standard deviation, which is 2. So 8 minus 6 is 2, divided by 2 is 1, z-score of 1. So that corresponds to this point on the chart. And we want to know the probability that that flu will last longer than 8 days. So within this region of the graph. So that's approximately 13.5% plus 2.5%. So about 16% probability that a flu with an average length of 6 days and a standard deviation of 2 would last longer than 8 days.